Good morning, guys. I have a test running in the background and I wanted to make a video on what the test is and why I'm running it and what the result will mean when we finally get it. My name is Stephanie Buchanan and I am a mathematical modeler and have experience in the fields of polymer physics, quantum chemistry, and mathematics. What I do for work is focus on thermodynamics and modeling chemical kinetics. My work focuses on amorphous recrystallization and how that affects physical stability. 5 years ago, I started to get interested in some big questions. And the one that I started with was, what is the shape of Earth? And so I fell into flat Earth theory, and I also came across crater Earth theory and toroidal Earth theory. And I started to model these different theories, and I wanted to see which ones held up under testing. So that's how I fell into testing big questions. And so I saw the pole shift conference earlier in May, and I was really interested in finding out about ECDO theory because I had never heard about ECDO. And so Ben really introduced that to me. If you want to learn more about ECDO theory, I highly recommend Inversion by Roger Cunningham. So that's when I started learning about ECDO theory. And I was really excited because I like testing models like this. I like testing big hypotheses. With ECDO theory, Roger has a lot of quantities to test. He has an exact North Pole coordinate. He has a 104-degree displacement. He has a collection of sites that all have bearings to NP prime. There are torque requirements, angular momentum requirements. There is an impulse requirement. There's a lot of questions that we can test. And so this made it testable. This made it easy to start with. And so what I started with was looking at the LLSVPs. I started with tomography, and I wanted to see where the preferred inertia axis of Earth, looking at the structures in the mantle, where that would lie. So that was really my first step in this process. And moving down, I started looking at EDC, and I finally got an opportunity to talk to Ben and asked him a bunch of questions about his model. If you want to learn more about Ben's theory, this is The Sun, the Earth, and the Disaster Cycle by Ben Davidson. Now we have two theories. Two theories for pole shift are both very well defined. They have different shell geometries. They have different preferred axes. And I have been thinking for a while, how can we test which model explains more of the data? Which model is closer to the truth? I think we have a test. I think we have a test that might work. So let me explain it to you. In the literature, they describe these large bodies, these blobs, and they are called LIPs, large igneous provinces. And these are connected to the margins of LLSVPs. Those are deeper in the mantle, but there is a known connection that is existing between the LIPs and the LLSVPs. So what I was thinking is, let's take those LIPs that are higher up in the mantle, rotate them 85 degrees because that is what EDC requires for its shell geometry reorientation, and see if they align better with LLSVPs. Because if they do, that would mean there was a rotation in the past. And with Ben's EDC model, it happens every 6,000 years or 12,000. I actually don't know if it's 6,000 or 12,000, but it is at least every 12,000 years. So we should be able to see that. What I'm doing is I'm looking at those LIPs from the Whittaker model using Earth bite data, and I am rotating them, so moving them 85 degrees. I am testing both ways and seeing if there's a preference to that alignment. If the alignment between LIPs and LLSVPs improves with an 85-degree turn, then we can say there's evidence that they did in fact move, and the shell is the only thing that's moving, not the entire shell mantle all the way down to the core boundary. I think we're going to get a good idea after this test. It's running, and I'm running 5,000 realizations because I'm testing that error. So that error, I'm propagating the uncertainty in the margins of the LLSVPs 5,000 times, and I'm running Monte Carlo simulations to test if it actually is a real result. I genuinely don't know which one is going to better explain that alignment between LIPs and LLSVPs. So we will see.